Hi everybody, I'm the greatest living inventor, and today we are doing my invention, fractal Lichen. So first I'll write it on the board. Fractal Lichen. Okay, so I'll read the description. The best way to make oxygen on Mars is with cyanobacteria. We maximize their surface using 3D fractals. Okay, so there's a lot of pages, so I'm not getting into what each and every word means. A fractal is something in mathematics you can see in Wikipedia. Shapes with the broken dimension, which basically means shapes that repeat themselves in smaller and smaller scales. And Lichen means a composite creature that is made out of fungi and algae, but we will, or fungi and bacteria. But we will, if you want, you can see it in Wikipedia. We'll read and try to go through the invention in a fast way. Okay, fractal Lichen. In order to colonize Mars, we need to have oxygen that we inhale, and we need to remove carbon dioxide that we exhale, which is toxic for us. In the Biosphere 2 experiments, okay, these were experiments, Biosphere 2. You can see in Wikipedia it now belongs to these buildings are now the property of the University of Arizona, and but before in 1994 they were used to check if humans and plants and animals can grow in a closed environment. And one of the conclusions was that they didn't have enough oxygen. The plants don't produce enough oxygen on their own, and you can see again in Wikipedia if you want more details. So we're going on. In the Biosphere 2 experiments, it was shown that plants alone are not enough. This is why scientists are testing cyanobacteria for this purpose. Okay, so cyanobacteria is one of the components of this. It's made out of fungi and cyanobacteria. And cyanobacteria, you may know them in the name blue-green algae. Blue-green algae. Because they are in the color blue-green. Okay, and let's go on. So this is why scientists are testing cyanobacteria for this purpose, for making oxygen on Mars. Okay, cyanobacteria and Lichen. These are the creatures that made Earth habitable, and they can do the same for Mars. Lichen is a united creature, a symbiosis or composite organism. Okay, it's composed of two things, made from fungi and cyanobacteria or algae. The fungi supply substance for the cyanobacteria or algae to grow on. All of these tiny creatures are very tough. They can live in deserts, they can live in the Arctic, and they can live without gravity. They can even survive for a period in empty space. My idea is how to make the most out of the cyanobacteria, because we need to terraform Mars soon if we want to live there, not just in bubbles or domes. The problem, they cannot grow on ground. The simple thing to do is just plant and grow lichen all over the ground of Mars. What's wrong with that? One, there's not enough surface area. Even on Earth, where the green-blue algae were multi-layered in the oceans, the oxygenation of the atmosphere took 300 million years. Of course, we don't have so much time, so we need a lot more surface area. Two, no sunlight. Mars has planet-wide dust storms. For example, the probe Mariner 9 had to wait months to send us clear pictures of the surface. This means we don't have sunlight on Mars, which is a key factor in photosynthesis. This also means we cannot grow things on the open planet surface because they will be covered in dust. See the famous last words of NASA's Opportunity rover: "My battery is low and it's getting dark." Okay, 3, maybe I'll write the points like in so you'll remember them. 1 is not enough surface. Not enough surface area. These are the reasons why we cannot grow the cyanobacteria just by putting it on the ground of Mars. 2, not enough sunlight. Dust storms. 3, abrasive filing. Okay, you know what filing is, like you do in a workshop, that you grind something. Abrasive filing, like file in woodwork or metalwork. Okay, file is also what you do for the nails, but after we cut the nails, we can, like women, do filing, so it's smoother. So the same you do in a workshop, so this is called filing, like in woodwork or metalwork. The dust sandblast and scratch like sandpaper, whatever it hits. So a greenhouse made of transparent glass or plastic will become opaque. Okay, so this is 3. Abrasive filing. I got the numbers wrong, but the next point, 4 it should be. No water. The lichen gets water and mineral nutrients mainly from the atmosphere through rain and dust. No water. Four or 5, in our case 5, no nitrogen. The nutrients for the lichen, which means nitrate, NO3 minus, which means nitrogen, which is also a problem on Mars. Would a settlement on Mars need to import nitrogen? Question mark. Okay, so 5. No nitrogen. Okay, so solution 1, grow above ground, 3D fractals. Basically we want maximum surface area in limited volume, which makes fractals ideal for the job. The fractals, okay, fractals. I'm not explaining what fractals are. You can see in Wikipedia. The fractal I have in mind is Sierpinski Tetrahedron, Tetrix, which is a sort of a hollow pyramid. Okay, so the solution okay, so these are the problems. The solution 1 is grow above ground in 3D fractals. And like the specific kind that I'm thinking about, Sierpinski tetrahedron. Okay, again, I'm not explaining what it is. It's interesting, but we don't have time. Think about it like a pyramid, which is hollow inside. Okay, or Menger sponge, which is a sort of a hollow cube. Or Menger sponge. Okay, so this is like a hollow pyramid. And this is like hollow cube. So, how do we create the physical fractal? When we create a fractal, for example, Sierpinski tetrahedron, we have 4 points of attraction. See source code in Wikipedia. I'll put a link for you. Basically, I'm just to make it reasonable to you, Sierpinski triangle looks like this. Okay, and in each triangle, it's divided into smaller triangles. Okay, and smaller triangles and smaller triangles. Okay, so this is Sierpinski triangle, and I don't have time to draw all the triangles. It's infinite, and you see that it's like there are many points, and when you program it, it's interesting, but I don't have time to explain it deeply. But you can see it if you look into Sierpinski triangle, or the three-dimensional equivalent, which is Sierpinski tetrahedron. This is in 2 dimensions. If you do it in 3 dimensions, it's a pyramid, a tetrahedron, which I call the pyramid just to make it simpler. So, but it's a tetrahedron, and you do it when you program it by an iterated function that repeats itself, and it chooses in random where to go. It's attracted to here, it's attracted to here, and it's attracted to here, and each time it takes half of the distance towards that. So I cannot explain it now, but this is how it's done. And we do the equivalent in the physical form. I'm talking about mathematical construct, but we are doing it physically, like in the real world. So how do we create the physical fractal? When we create a fractal, for example, Sierpinski tetrahedron, by the way, we cannot do it here on Earth in 3 dimensions. In 2 dimensions we can, with like a flat surface. But in 3 dimensions we can't, because gravity will make the particles fall. But in space we can do it, and this is what I'm using. I'm taking advantage of the fact that we are in space. When we create a fractal, for example, Sierpinski tetrahedron, we have 4 points of attraction. See source code in Wikipedia. In building the fractal physically, we will replace these 3 magnets that will attract iron filings that will float between them. Okay, like we have in demonstrations you do in the classroom, when you have like in school, where the teacher shows you how the magnetic field looks like. Sorry. Sorry. So it's the same thing. We are and he puts he or she, the teacher, puts iron filing, dust made out of iron, and the magnet shapes it to a specific shape. So it's the same thing here, but with a few magnets in the corners of the pyramid. In building the fractal physically, we will replace these 4 magnets that will replace these attractors with 4 magnets that will attract iron filings that will float between them. In order for the iron filings to float, I suggest we build this thing in space where gravity will be negligible. We think about it like no gravity. For our purpose, we want cyanobacteria to populate as much surface as possible, so our iron filing will have a mixture of glue and ground powder of lichen. Okay, so on the iron filings we put glue, plus lichen powder. Okay, we grind the lichen and put it on the iron filings with glue. Okay. It's important to make sure that the tiny amount of glue only sticks to the iron filings, only sticks the iron filing to the lichen, and not to each other, not the iron filing to the iron filing. In parentheses, let the glue dry after iron and lichen bonding, close parentheses. The growth of the lichen, the fungi fibers, will allow the structure to solidify and keep its delicate form, and after it dried we can remove the magnets and it will not collapse. Okay, so after the lichen, let's draw them in blue and green, because it's blue and green lichen. So after they populate this and make fibers all over the place. So we can, at the beginning, we have magnets. Okay, like this is a magnet. And here a magnet, and here a magnet, okay? Of course, it's not really, it doesn't look like this, it's electromagnets, which we shut off, so they disappear, they appear and they disappear at the same time, but I'm drawing it just for simplicity as bar magnets or horseshoe magnets. But it's not horseshoe magnets, it's not a constant magnet, it's electromagnets. Okay, so this is just for making it friendlier. Okay, so when we after the lichen grows a little, it's like it makes fibers, okay, and the fiber holds this thing together. So it's like then we can take away the magnets and the structure stays the same if it's in space, if there is no gravity to collapse it. Then it stays like this, even without the magnets. Okay, so where do we place the sponges? I will call these sponges because one of the forms is a Menger sponge. Well, so this I call a sponge, even if it's the other kind of hollow pyramid or hollow cube. Anyway, I call it a sponge. So we call this a sponge. So where do we place the sponges? So I'll erase the board and I will explain. Let's see what's the time. 25 minutes. Where do we place the sponges? Okay, and the sponges, I mean these pyramids with the green and blue. Okay. Okay. The wall of the ball needs to be thick enough to withstand the pressure inside. Just looking. Okay, so not sure if I explained this already. We put them in like a small aquarium. Okay, it's like imagine that we put them like in a small aquarium. I will explain in a second in what exactly we put them. But the wall of this tiny greenhouse needs to be thick enough to withstand the pressure inside. Outside is the vacuum of space and not to explode. Okay, because inside it's not vacuum. Inside there are gases like in the beginning CO2 and after this oxygen that they produce. So this protection needs to be thick enough. Here. To withstand the vacuum. Otherwise it explodes. Okay, here is vacuum, here is pressure, and it explodes. Then periodically we harvest the gas inside it, like pumping air into a basketball, but in reverse. Take the O2 rich air and put in instead CO2 rich air. Okay, so after a while they produce O2 and oxygen, and we take this oxygen and we put instead of it CO2, and they produce more oxygen. Okay, what they know how to do is to take CO2 and to produce oxygen. This is called photosynthesis. So maybe I overlooked it. It's like I thought it's obvious, but it's not obvious. This is what the cyanobacteria knows how to do, to take CO2 and to make from it oxygen with the energy of the sun and with the whatever it needs, like water. Okay. If we put the lichen sponges on the ground of Mars, the gravity will collapse them under their own weight, but in space they remain standing. Okay, battle garden. So this is basically what this is. The next part is taken from the idea of a terrarium, or the small-scale version, the battle garden. Okay, so again, it's like an aquarium for plants. Instead of for fish, it's for plants. If you've never seen one, it's a glass jar with a little soil inside and a plant growing in it. The plant has a little water to start with and a little air to start with, and then the jar is sealed. But the plant can live there for many years, sometimes decades, because it circulates the water. The vapor from the soil go to the jar ceiling, where it condenses and drops like rain, and also circulates the air. The plant breathes O2 and also generates O2 by photosynthesis. Okay. In fact, all the plant needs is sunlight. Okay, so the water vapor. Okay, if we think about water, there is water vapor in the air, and then it touches the cold glass, and then it becomes drops, and then they drop to down, like there is no down here, but it's like this is what happens. They become drops, and then there is a circle with the plant. The plant recycles its water and recycles its air. Okay, because plants breathe too, they just also produce oxygen, but they also breathe it when they don't do oxygen. Like at night. In here, it's at night, and there it's we'll explain when they sleep. Don't do photosynthesis. Okay. In fact, all that the plant needs is sunlight. Okay, 34 minutes almost. So my idea is to put the fractal sponges inside big sealed jars like that, or even better, create them in the jars to start with. In parentheses, magnetic field can pass through glass. Close parentheses. Ideally, the jars will be completely round like spheres, or at least cylindrical. So the other shape that we can use is a cylinder. Okay, this is also good for us with the plants inside. I call these plants, but you see it's like the sponges, the cyanobacteria. Ideally, okay. Ideally, the jars will be completely round like sphere, or at least cylindrical, so they can be rotated and get sunlight from every angle. Every bottle will be sealed except two hole openings on opposite sides of the round jar, like here and here. Okay, so here it will have an opening, and here it will have an opening, and like it's normally it's closed. Think of it like a cork or like a lid of a jar. Okay, every bottle will be sealed except two holes openings on opposite sides of the round jar, which will be closed in a way which we can open at will, like screw cap of a bottle or a jar's lid or a cork stopper, etc. These holes openings will be used when the jar is ready, which means when it got to its highest oxygen capacity, to its highest oxygen capacity, or close to it. We will suck out the oxygen through the hole and fill it instead with CO2, and this jar working starts again. I think sucking the gas oxygen out of one hole while pumping the other gas CO2 into the other hole is the most efficient way. Okay, now the next step, Lichen solarium. Lichen solarium. Okay, solarium is a place where you get sun. Before I'll start to explain how the solarium is made, I want to point out that it should be located in the Lagrangian point, so it will stay fixed in space near Mars and will not fall on Mars. Okay, Lagrangian point, I'm not explaining, but it's a special point. Okay, so we want to pack all this glass bottle tightly, but at the same time give each of them time to be in the sunlight. So I took inspiration from the emperor penguins in Antarctica who huddle, okay, huddle. This is what penguins do. Emperor penguins in the South Pole, not in the South Pole, but in Antarctica, not far from the South Pole. Emperor penguins in Antarctica who huddle, crowd together, and switch between themselves in a way that each one of them will get to be part of the time inside and the other part of the time outside, in a fair way, and no one will freeze. Okay, I don't have time to explain. It's interesting, but I don't have time to explain. They are in a big group, and outside it's cool, and inside it's hot because they are close together, so they rotate between themselves. They are like shifts. One goes outside and then it goes inside, and they change places all the time. It's interesting to know that it can really be modeled mathematically. See this mathematical paper by Aaron Waters, Françoise Blanchette, and Arnold D. Kim, Modeling Huddling Penguins. Okay, it's a research paper. modeling Huddling penguins, about emperor penguins, and it's by Aaron Waters. Okay, since I'm short on time, I will just put it in a link in the description. Okay, the balls will be held, these balls will be held from the two opposing lids or caps by two screws together, forming a gentle vise like in a workshop between two firm grids made of metal. Okay, so it's like we have this device in a workshop that okay, it's like I'll show you one instead of drawing. Okay, it's something like this, but like professional. But you can rotate this, and the screw presses against the device. Okay, so this is called the vise. Okay, vise. And okay, I don't know how to draw it now, but it's something like this, and it screws into the frame, and it presses from here and presses from here. So we hold this and this inside between a vise, of course, without breaking it. Okay, the balls will be held from the two opposing lids or caps by two screws together, forming a gentle vise like in a workshop between two firm grids made of metal. Okay, so there will be many balls or cylinders, if you prefer cylinders than cylinders. There will be many battle gardens like this, and they are each of them has lids, and they are between two layers of a frame, one here and one below. Okay, this is also in this direction. It's like a grid. If you look on this from the side, it looks like a line, but if you look on it from above, this is a grid. Okay, grid. So made of metal, between two firm grids made of metal. This is a grid and this is a grid. The grids can be something like a 2D rebar, okay, like a rebar. The grid of reinforcing steel bars that's used in reinforced concrete. There will be utility robots that run on these tracks and switch between the between the balls in the same algorithm as the penguins. Okay, I'll write. No, I don't have time. Each layer of glass balls is sandwiched like a sandwich. Two metal grids between two metal grids, but it's not a simple sandwich, it's more like a bagel. Okay, so if we look from above, it's like a round. Okay, this is like a round shape. And in the middle there is a hole. Okay, so this is what I mean, it's like a bagel. If you don't know what a bagel is, think of a donut or a torus shape, a ring with a hole in the middle. So this hole that is in the middle of our bagel is used for skewering, impaling the bagel on a long shaft. This shaft is basically a big pipe. Okay, so there is a big shaft. Okay, that goes through here, through the hole, and comes out in this side, and it goes through all the bagels, like there are bagels on top of each other. So here there is a bagel from below this one, and here another one, and so on. Okay, the shaft is long and there are bagels on top of the shaft. The shaft is going through the bagels. So this hole is in the middle of our bagel, is used for skewering, impaling the bagel on a long shaft. This shaft is basically a big pipe. We have many, okay, this is a big pipe. But we call it shaft. Okay. We have many bagels skewered on the shaft, one above the other, like shish kebab. The whole structure will look from the side like a corn on the cob, served on a stick, a skewer, which is the shaft pipe. So this is like corn on a cob, like corn on the cob. And this is the skewer. I apologize for all the food metaphors. It just seems to be the best way to explain visually what I mean. I wrote it in the book, or it's 23:21, like 20 minutes past 11 p.m., and I should make supper. The tiers or bagels, okay, this tier, this tier, this tier, of sandwiches of grid from above and grid from below. This is the bagels. So these bagels are separated by the distance that allows the robots to work. Okay, so on these bagels there is a robot that works. That makes this shuffle of the battles. If the utility robots are impractical, we can leave the idea of switching and use another system. If the balls want in this alternative system, we don't want the corn on the cob to rotate in space with the robot. Instead, we want it to stay, for example, with the sharp tip of the skewer, the head of the shaft, towards the sun. And then we will use mirrors to concentrate the light of the sun and optical fiber cables to run the sunlight down to all the plants using beam splitter on each tier, on each bagel. Okay, so I'm short on time. I wasted 50 minutes explaining to this point, so now I'm doing it a little rushed. But the sun is here, and we have optical cables that bring the sunlight that is concentrated by mirrors in the Lagrangian point to a single point, and from there we deliver it exactly to the battles. Okay? With a beam splitter on each tier, on each bagel. In each tier, the sunlight will be brought without waste through pipes with optical fiber, in the same way that drip irrigation is used with water. Okay, it doesn't waste water, and in the same way, we don't waste sunlight. Okay. The big pipe has a hole opening with non-return valve. Okay, so down here, let's say in the end of the pipe, there is an opening with the valve. Okay, I didn't draw the valve, but it is a valve, and with a non-return valve that lets the gas flow in one way and not back. Imagine the whole pipe like a flute with holes, but each hole is one directional inwards instead of a real flute which is outwards. A flute doesn't have valves, so it's like a flute but with valves, and the valves are inwards. Okay. These holes drain the oxygen from all the tiers into the big pipe of the shaft, and from there we collect it with a space shuttle and take it to Mars for the people to breathe. Okay, so the space shuttle comes here and takes the oxygen to the people. And it takes all the oxygen and flies away. And also it fills this with the new CO2. Okay? Okay. So solution, all this was solution 1. Now I'm talking first about solution 2. Solution 2. Okay, so solution 2, grow underground. Okay. An alternative approach, which some might find more grounded, haha, pun intended, is to use the only point that rises above the storms, the dust storms. Olympus Mons, which is the largest volcano and the tallest planetary mountain in our solar system. Okay, so on Mars, this is Mars, and there is a mountain which is like half of Mars, Olympus Mons. Okay, it's like the biggest mountain in the solar system. One obvious drawback is that it may still be active volcano with the potential to erupt. But we assume it's not very active. Okay, so what we do is make a set of mirrors on the top. Okay, so it's a volcano, so it's actually a volcano looks like this. And we put mirrors. Okay, let's draw them in like this, mirrors here, mirrors here, mirrors here, mirrors here. And all this is mirrors. Mirrors on top. Okay, so what we do is make a set of mirrors on the top of the mountain and concentrate the sunlight into lava tubes, which are empty now, and grow the lichen there, where it's protected from dust. Okay, so inside the mountain there are lava tubes. Okay, this is lava tubes. And it's protected from the dust storms. Of course, if there is a dust storm, it cannot go inside the lava tube. We are talking inside the mountain. So it's protected from the dust. If the lava tube goes all the way to the surface, Olympus Mons is 2.5 times the height of Mount Everest, then we can use the fact that the O2 is lighter than CO2, so at the ground there is only CO2. Okay, but it doesn't have to be, even if it's like only a small portion of the mountain. We take the lower, we drill into a hole into the lower part, and this is the bottom of our one big bottle. Okay, the CO2 will be more heavy, and the O2 will be above. So at the ground there is only CO2. So after we clean the lava tube from dirt, we put the lichen there. Of course, it will not be in fractal formation because of the gravity, hence less effective. But we do it with the mirrors and with the fiber optics, okay? So from here we have fiber optics. Which is like a pipe for the light, and blow air from the bottom end of the tunnel. Okay, we can use fans. Okay, so again, so after we clean the lava tube from dirt, we put the lichen there. Okay, so the lichen will be in here. Of course, it will not be as effective as the fractal formation because of the gravity. It cannot be in this nice shape. And we blow air from the bottom end of the tunnel. We can use fans like they use in tunnels through mountains on Earth to keep the air fresh. Here we are keeping the air full of CO2 for the lichen. Okay, so when this is full of oxygen, we blow more air from outside, and the air from outside is CO2 on Mars. On the other side, at the top, we need to somehow collect the O2. Okay, so we blow air from the bottom. From here, we blow air, we blow in CO2, and we get from the top, we get O2, which is oxygen. We can use fans like they do in tunnels through mountains on Earth to keep the air fresh. Here we are keeping the air full of CO2 for the lichen. On the other side at the top, we need to somehow collect the O2 by centrifuge or something. The air will be richer in O2, but we should purify it more. Okay, so it's not breathable yet, but it's got a lot more O2 than CO2. Okay, so this is my invention, and I hope it was clear. And thank you very much. I'll see you in my next invention. Thank you. Bye-bye.